In section 7.8, we're going to study what's called variation. This is something that's very practical and has a lot of applications in sciences, business, and all sorts of things. Variation happens when, if one quantity changes, there's a corresponding change in another quantity. For example, when you go shopping, as the number of items you buy increases, the cost of those items would increase. That's going to be what we call direct proportion or direct variation, where one thing increasing causes another thing to increase. So for example, suppose a grocery store sells bananas for 65 cents each, and T is going to be the cost and B is the number of bananas. Well, the cost would be 65 cents times the number of bananas. So you'll notice we have one variable equals a number times another variable. Or suppose we have this one. An inch is equivalent to 2.54 centimeters. And if I is the number of inches and C is the number of centimeters, the number of centimeters is equal to 2.54 times the number of inches. This is a kind of situation that comes up quite a bit. When you're converting from one quantity to another one, you have an equation like this, where you have K, or a number. We're going to use the variable K in a minute. You have a number that is a constant multiple. Some people call it a conversion factor. Here we're going to call it in a minute a constant of proportionality. But anytime you're reading a word problem, you might see something like one variable varies directly as another variable, or one variable is directly proportional to another variable. Or sometimes they don't even put the word directly and they just say one variable is proportional to another variable. If we don't know what that constant multiple is, we're just going to use the letter K. And we would say one variable is a constant K times another variable. So the equations we're going to set up for this kind of problem are actually some of our simpler equations. It's just one variable is a number times another variable. So let's take a look at our first example. It says, during a thunderstorm, you see the lightning before you hear the thunder because light travels much faster than sound. And our next sentence is the key one. The distance between you and the storm varies directly as the time between the lightning and the thunder. So before I even read the rest of the problem, when I see that it says distance varies directly as the time, the varies directly part tells me it's going to be one variable is a constant times the other variable. So distance varies directly as the time. I just have D equals KT. That's going to be the key part for this section, is reading the problem and getting the right basic equations set up. So now often the way these problems are going to go, we're going to be given some information that helps us figure out what K is, what that constant of proportionality is. In this case, it says, suppose the thunder from a storm 5,400 feet away takes 5 seconds to reach you. So 5,400 is a distance. So we'll put that in the distance part of our formula. We don't know what K is yet. We're going to find that out here in just a minute. And then 5 seconds is a time. So here we have 5,000 equals K times 5. Oh, I made another mistake, didn't I? That was supposed to be 5,400, not 5,000. That's the correct number. So 5,400 equals K times 5. And now to finish the problem and figure out what K is, we divide both sides by 5. And we would have 1,080 equals K. So now that we know what that constant is, this is a key step that a lot of students skip, and I really want to encourage you to do this. Go back and write out that equation. We know what K is now, so we can say D equals, and instead of KT, it's 1,080 T. So knowing that, let's look at the next one. It says, if the time interval between lightning and thunder is now 8 seconds, how far away is the storm? 8 seconds is a time, so we're going to put that in our new formula that we just found for T. And we would have D equals 1,080 times 8, and we get 8,640. But we need to put the correct units, and the units for distance on this problem are feet. So 8,640 feet would be the answer. This is a good description of how the problems in this section are generally going to go. Step 1 is reading the problem and setting up a basic equation. Step 2 is using some information that you're given in the problem to figure out what k is so that you can write out the equation with a number in place of k. And then the step 3 is going to be answering the final question of the problem. So let's practice those steps as we go through another example. But before we get to that one, we need to talk about a different type of variation. Sometimes instead of one variable is a constant times another variable, we're going to have equations where one variable is a constant divided by another variable. That's going to be what's called, instead of direct variation, inverse variation. So if you see something where it says one variable varies inversely as another variable, or one variable is inversely proportional to another variable. If it says inversely instead of directly, then when you're setting up the basic equation, instead of a variable is k times a variable, it's going to be one variable is k divided by another variable. So with that in mind, let's look at our example here. It says, Boyle's law states that when a sample of gas is compressed at a constant temperature, the pressure of the gas is inversely proportional to the volume. So pressure is inversely proportional to the volume. Inversely is the key word here. That lets us know that it's going to be one variable is k divided by another variable. Here for pressure, I'm just going to put P. For volume, I'm going to put V. So that's my basic equation. That's the key step that you want to practice and get really good at, because the rest of it is going to be comparatively simple equations in comparison with what we've been dealing with. All right. So here it says, suppose the pressure of a sample of air that occupies 0.106 cubic meters at 25 degrees Celsius is 50 kPa. The kPa stands for kilopascals, but that's not really crucial to know for this problem. Find the constant of proportionality and write the equation. So we need to figure out what to put in for P and what to put in for V. So let's look at these numbers. This 0.16 cubic meters, that's a volume. The 25 degrees Celsius, that's a temperature. And the 50 kPa is a pressure. So here for pressure, we're going to put in 50. We don't know what K is yet. That's what we're going to try to find. And our volume was 0.106. It turns out we didn't need that 25 for this problem. So that's our basic equation. Now here, to get K by itself and get rid of that 0.106, since it's on the bottom of a fraction, we multiply both sides by 0.106. So 0.106 times 50, we end up with 5.3 equals K. So going back, now that we know what K is, we can write our equation. Instead of P equals K divided by V, we can write P equals 5.3 divided by V. So then it says, if the sample expands to a volume of 0.3 cubic meters, find the new pressure. So our volume is 0.3. We're going to plug that into our equation. P equals 5.3 divided by 0.3. Now here, when I do that on my calculator, I get a really long decimal. I'll just round it off to, since this one was 3 decimal places, I'll give it 3 decimal places. 17.667. And pressure, our units for this problem are the kPa, the kilopascals.